welcome to Calculus with Lauren, with my company Luminaries and Fireflies. I'm an artist and educator, and I'm starting a new series all about calculus. So I'm going to start calculus with Lauren with derivatives. This is a mixture of high school and college-based derivative. It's mostly college-based though, so this is meant for Calculus 1 college students. Okay, so the derivative, what is it? A derivative of a function of x is the slope of a tangent line through a point on the function x f of x. So that's just a point on the graph. It is also known as the instantaneous rate of change of the function x. So rate of change can be anything from a curve. So it's changed from this point to the next, to the next, to the next. So it's an instantaneous slope going up that line. Okay. So what does that mean? The triangle here means rate of change. So we've been studying slope since we were kids. Slope is usually identified as m, or the change in y, so you're up and down, over a change in x. And then x is your horizontal change if you're going left or right. And here's a little graph example. So one thing that people get confused about is what is a tangent line. A tangent line is notified by these little purple lines here, and it's going through the point at the slope that that point has instantaneously at that moment. And so it has the same point as the function does at x comma f of x. So in this case right here, for this one, at 4, 4, that tangent line goes through 4, 4, and so does the function. And you use that tangent line to find that slope there, right at that moment. So here's another example right here with the tangent line at 2, 1. It shares it with that function, and its slope is going upwards in a positive direction. Okay. So this one's more specifically about the formula of it. I'm going to make another one that's about limits, and another video as well that's more so about what can you use the derivative to find. And I'll do that after we're more comfortable with going through the formula itself. So the formula for a derivative is the prime f of x equals the limit as h approaches 0. H in this is just your change in x, which I put up here. Your change of x equals h. So it's the same thing. A change in x is just when you move from this point to the next on the graph, a change in x. So if you want, you could always rewrite your formula right here with change of x here, or change of x right there as well. Okay, so whichever way you want. I put h just because it's a simple variable. I can write quickly. So the prime of f(x) equals limit of h as it approaches 0, f of x plus h minus f of x over h. Okay, so this is probably the most confusing part of this formula, the f of x plus h. F of x is really just, you're given a function of x, so f of x equals x squared, for example. You would just plug in x squared for f of x. Okay, so the best way I think to learn this is through practice. And so let's try a few of examples. And just to tell you, again, reiterating, f of x plus h is the same as f of x plus change of x. So the change of x on the graph. F of x plus change of x means going from one point to the next to find the slope. Okay, so the next slide. Formula for the prime of x equals f of x plus h minus f of x over h. In order to solve for this, you'll replace x in the formula for this one with x plus h, and then you'll simplify everything. This example 1, we're using f of x equals x squared minus 6x over 3. So right now we're finding f prime of x and f prime of 3. So when you have a number on the bottom here, I usually recommend rewriting it in terms with the fractions rather than a whole division sign underneath the whole function. So to rewrite it, f of x would be 1/3 x squared minus 6 divided by 3, which is just 2. So 1/3 x squared minus 2 of x. I'm going to separate everything up into a smaller thing so it's easier to follow. So we're going to start with this part of the function that says f of x plus h. Like I said here, you're just replacing x with x plus h in this f of x formula. So to do that, you would have 1/3 of x plus h squared minus 2, replace that x with x plus h. Okay? I'm going to go ahead and simplify this so I can get everything fleshed out in a bit. Next, it'll be minus f of x, right? So what's f of x? Literally just plug that in. So it would be minus 1/3 x squared minus 2x. And then everything is always over h. So I'm rewriting here. So x plus h squared minus 2 times x plus h all over h. Oh, so that's it. Now, always put parentheses in everything when you plug it in. Reasons for this, when you're subtracting f of x, that negative is going to affect everything within your function. So I'm going to go to the next slide. Alright, so we have 1/3 x plus h squared minus 2 parentheses x plus h minus parentheses 1/3 x squared minus 2x all over h. Okay. So let's flesh this out a little bit. I'm going to do this first. So how do you do x plus h squared? I'm going to work it on the side here. So we have x plus h squared. That's the same thing as x plus h times x plus h, isn't it? It's just a factoring, right? So you'll multiply x times x, you get x squared, x times h, you get xh. Do the same here with h times those, plus xh, plus what's h times h? H squared. So make sure you do x times x times h, plus h times x, h times h. Okay. This would simplify to x squared plus, we have two of these that have the same terms or the same variables, so you'll have 2xh plus h squared. Now we can plug this back into the formula over there. So now we have 1/3 parentheses x squared plus 2xh plus h squared minus, I'm going to go ahead and multiply 2 in just because it's a regular distribution. So negative 2 times x is minus 2x. Negative 2 times positive h is minus 2h. I'm going to carry this negative through as well so we can get everything kind of on a straight line here. So you'll have minus 1/3 x squared. And then negative times a negative is positive, so negative 1 times negative 2x is positive 2x, okay? And this will all be divided, that's a terrible line, all be divided by h, okay? Now you can also go ahead and distribute this 1/3 into everything so that everything can be ready to start eliminating. Because the major thing with this function, most things end up getting eliminated. And it makes it much easier to deal with. So we have 1/3 x squared plus 2 divided by 3 is just 2/3 because you cannot simplify that. 1/3 times h squared would be plus 1/3 h squared minus 2x minus 2h minus 1/3 x squared plus 2x, and then everything is divided by h. Alright, everything divided by h. Okay. I see a lot of things that have in common. So, let's look at this first term. X squared. We're looking for anything else that has x squared so that we can simplify. Over here we have x squared. 1/3 x squared minus 1/3 x squared, same thing, but opposites, so they'll cancel out. Next, is there anything that has an xh? No, so this guy's going to stay. Next we have 1/3 h squared, nothing else has that, so that will also stay. And then we have negative 2x and positive 2x, so those will also cancel. And then we're left with negative 2h as well. That doesn't have a counterpart, so let's rewrite everything. So this will be 2/3 xh plus 1/3 h squared minus 2h all divided by h. It looks so much easier now, doesn't it? Now, notice that everything has an h here, and you're dividing by h, which means every single one of these terms individually you can divide by h to simplify. If I did that in this first term, 2/3 xh divided by h, the h's will just cancel out, so you'll be left with 2/3 x. 1/3 h squared, if you divide h squared divided by h, you're eliminating one of the h's, so you'll be plus 1/3 h minus 2h, h will just eliminate again, so you'll have minus 2. That looks so much simpler, doesn't it? Okay, so from the beginning, I know I didn't explain limits very much in this video, but go to my other video for limits once I create it and post it to get a little more information. So when I put prime f of x, the beginning of the formula said the limit as h approaches 0. And now we have this simplification of it, 2/3 x plus 1/3 h minus 2. When you have a limit approaching 0, you would just plug in h equals 0 into this so you can simplify and find f of x. So if I plug in 0 for this, for that, what's 0 times 1/3? Anything times 0 is 0. So our f prime function equals 2/3 x minus 2. Okay? So that's how you work that. Now, that wasn't the only question that it asked. So now we have 2/3 x minus 2 equals f of x. So I'm going to write that over here. F prime of x equals 2/3 x minus 2. Let's write that 3 better. 2/3 x minus 2. Okay. It also asked us what f prime of 3 is. So just like when we put x plus h in place of x, because it was in those parentheses, we'll do the same, but do it with 3 this time into the formula that we just found. So instead of f prime of x, we're going to find f prime of 3. You're just plugging 3 into any term x that's on the formula, so you'll have 2/3 times 3 minus 2. 3 divided by 3 cancels out, so you're just going to end up with 2 minus 2, which cancels out as well, leaving you with 0. So f prime of 3 equals 0. So what is that telling us? What is that finding? So if you're going to have a graph and you had a point at x is 3, wherever it is, the slope is what we're finding. Your derivative gives you the slope at that point x at 3. So our slope at 3 is 0. What is 0? 0 slope is a constant slope. Anything that has a slope of 0 means that, an example could be if it's at the top of a curve. So this right here is a positive slope going upwards. Once it levels out again, it goes to 0 before it can start going down again, meaning going to a negative slope. So a constant slope is just a flat line that it gets to in order to curve again. Another constant example would be something like this, if it leveled out to 0 here. If your slope y equals 0 here. Okay, so constant means it's either curved out or curved back up, or done something like this, where it went to 0 and then went back up again. There's a bunch of different examples of what a constant slope would be, and I'll go through that in another video. Right now I just want to do another example. Okay, so to get on started, I'm going to do a second problem here that has a little bit more information that we're solving for. So our formula this time is f of x equals the square root of x squared plus 1. This is going to be a complicated problem, so try to follow along and pause whenever you're having trouble, rewind and rewatch. I'll try to do it slowly so it's not too difficult. Again, our formula for f prime of x, or your derivative, your first derivative, equals the limit of h approaching 0 when f of x plus h minus f of x all divided by h. So I rewrote it here just so we can kind of work along it. And it's telling us to find the derivative, which is using this formula, and the equation of the tangent line at x equals 2. Tangent line is, just remember, a line going through that point that will give us the slope. A line has the equation of y equals mx plus b, which is something that at this point you should be rather familiar with. M being your slope at that point, so it's going to provide you the slope. B is your y-intercept, and then x will be 2 in this case. So we'll plug in 2 once we find that equation for the tangent line, so we can solve for it. Okay. Moving forward, our equation for f of x is the square root of x squared plus 1. Our equation for f of x plus h, remember you just plug in x plus h in place of x, is going to be the square root parentheses of x plus h squared plus 1. Okay. And then our f of x is the square root of x squared plus 1. So let's go ahead and plug everything into the formula of f of x function derivative equals the limit of h approaching 0 of f of x of plus h, which we're just going to plug that in right here. Same thing, just repeat it. All under the square root, minus parentheses x squared plus the square root of x squared plus 1. All divided by h. Okay, so this one gets a little confusing because we're going to do something what's called a conjugate. A conjugate is the opposite of the top of the function or the bottom of the function that has square roots involved, because you need to eliminate them in order to make things simplify. If you look at this right now, there's not much we can do to simplify it other than multiplying by itself. So a conjugate is you change the sign in order for it to cancel out different parts of itself. When you multiply a square root of something times a square root of itself, it makes it squared under a square root, which is the same, which equals itself. So to give you a quick example of square roots, if I did the square root of 2 times the square root of 2, that would equal the square root of 4, or the same thing as 2 squared. Anything squared under the square root equals itself. So the square root of 4 equals 2, the square root of 2 squared equals 2. So if I had the square root of x squared plus 1, and that was squared under here, it would just equal the x squared plus 1. If I had x squared plus h squared squared under here, it would just equal itself, x squared plus h squared. Okay? So that's just a quick little information. I'm going to erase that so so we can move on and have some space. Okay. Alright, so the conjugate of this, you're going to be using this top part here. You're doing the square root of x plus h squared plus 1 plus the square root of x squared plus 1. So you have the minus on this side, you're going to put a plus on here. What you do to the top of an equation, you have to do to the bottom. And that's an old algebra rule. Plus 1 plus the square root of x squared plus 1. Okay, so when you have opposite signs here, when you do a regular factor of like x plus h times x plus h, it ends up having x times h and x times h twice, so you always end up with 2xh. But this has two positive signs. What if we had a negative sign? So we have x plus h times x minus h. It would be x squared. X times negative h would be minus xh. X times positive h would be plus xh minus h squared. Don't these two middle terms cancel each other because they're opposites? Yes. The same thing will happen in this case. So, if we do this times the first part, it's going to be itself squared because it's the repeat of itself. So I'm going to go ahead and write it out so you don't get confused. But I have the square root of that times the square root of itself, which means this will be squared. Remember, the square root of something that's squared is itself. Okay, so then this times the positive version, so factor here, sorry. So you have the square root of x plus h squared plus 1 times the square root of x squared plus 1. And now we're using this guy, the negative one, so he needs to multiply by this one and the back one. So when you multiply by the front, it's minus the square root of x squared plus 1 times the square root of x plus h squared plus 1. Aren't these the same thing? Yes. So positive and negative version will cancel them out. So then the last thing we have to multiply is just the last two terms. So it'll be minus the square root of x squared plus 1 squared. Okay, because it times itself under the square root here, which means that square root is going to cancel as well. And then don't forget the denominator. We also multiplied h times this on the bottom. So I'm going to go ahead and simplify the top real quick and then write it how it's going to be. So the square root of something squared is itself, so you'll have x plus h squared plus 1 minus x squared plus 1 all over h times the square root of x plus h squared plus 1 plus the square root of x squared plus 1. Okay? Alright. So, on this top part we had x plus h squared plus 1. Make sure, yes, plus minus x squared plus 1. Okay. So, it's important to remember that the negative has to distribute into both terms of the f of x function. So to rewrite that, it would be that x plus h squared plus 1 minus x squared minus 1. So already I see this plus and this minus here. So I'm going to cancel those out and rewrite it back down here. So you'll have x plus h squared, that plus and minus 1 canceled, leaving us minus x squared, all over h parentheses the square root of x plus h squared plus 1 plus the square root of x squared plus 1. Okay. I haven't worked it out for you yet. So let's go ahead and flesh out the x plus h squared now. We've done this a couple of times before, so x plus h squared is just x plus h times x plus h So you just FOIL it, and you end up with x squared plus 2xh plus h squared. So I'm going to plug that in place of x plus h in the rest of this problem and go from there. So I will then have x squared plus 2xh plus h squared minus x squared all over h times the square root of x squared plus 2xh plus h squared plus 1 plus the square root of x squared plus 1. Okay, looking at the top, like we did with the last problem, we tried to simplify everything else out. We've already simplified the plus and minus ones, so now we're going to look at the rest of the terms. You have x squared and minus x squared, so these two terms will also cancel out, leaving us with the top, that's 2xh plus h squared, all divided by h parentheses, all this stuff here, so the x squared, I'm just going to put little parentheses, because you just repeat it, plus the other square root. Okay, so I'm going to ignore this big term dude here, this guy, because this top we can divide it by h without having to worry about all those square roots on the bottom on the other part. So 2xh divided by h is going to leave you with 2x, because the h is canceled. H squared also has to be divided by h, so plus h squared divided by h would be plus h, all divided by this guy, so x squared plus 2xh. Okay, so still a little messy, but it's not going to be too bad, I promise, because a lot of these things are going to have zeros. Because remember, the beginning of the function said f prime of x equals the limit as h approaches 0. So you make 80 equal to 0 and you plug it into here. Okay? Let's go ahead and go to the next slide. So we have f prime of x equals 2x plus h all over that whole mumbo jumbo. I rewrite it every single time just so I don't confuse you. So our limit approaching 0, let's plug in 0 for h. So 0 right here, a 0 right here, and a 0 right there. So we have 2x plus 0 all over the square root of x squared plus 2x times 0 plus 0 squared plus 1 plus the square root of x squared plus 1. Okay, if we simplify everything that has a 0 in it, we're left with 2x on top. This 0 turns into 0, so does that. So that means we're actually only left with x squared plus 1 right here, plus square root of x squared plus 1. Okay, so when you have 2 of something, here it'll turn into 2x over 2 of the square root of x squared plus 1. And then we have 2 of these 2's here. So if you want, you can also cancel the 2's and just leave yourself with x over the square root of x squared plus 1, making it easy peasy. This doesn't answer everything that we're looking for, so right now all we have is what is the derivative, which is x over the square root of x squared plus 1 by itself. What it wanted also was the equation of the tangent line to this at x equals 2. A tangent line just has the formula of y equals mx plus b, because it's just a straight line going in any direction. It can be positive, it can be negative, etc. Depending on what the slope is, at that one point on the graph. Because remember, graphs can go all over the place, so it can be positive, it can be negative, it can be constant and straight at 0, etc. Okay, so first off, we need to find the tangent line. I recommend finding the slope first. What does the derivative find you? The slope at that point. So now we can plug in x equals 2 into our derivative formula we just found and solve. So our f of x, which will now be f of x at 2, right, prime, equals 2 over the square root of 2 squared plus 1, which would just be 2 over the square root of 5. I like to get rid of my square roots on the bottom, and to do that you just multiply by the opposite or the same, so you can get rid of the square root. Square root of 5 times the square root of 5 is the square root of 25, which is just 5. So we'll be left with 2 square root of 5 over 5. And remember, this equals our slope, so m is what our variable for slope is. M equals 2 square root of 5 over 5. And then if you plug that into the formula, we still only have m and x equals 2. So we're missing b, but how do we find that? Well, one good thing is we had the equation at the very beginning. Remember, f of x equals the square root of x squared plus 1. If you plug in x equals 2, you could solve for y. You could find what your exact coordinate point would be. So remember, f of x just equals y. It's the same thing. So f of 2, because x equals 2, equals the square root of 2 squared plus 1, which is just 2 squared plus 2 squared is 4, plus 1 is the square root of 5. So now we have y, m, and x, and we can plug them in to solve for b. I'm going to go ahead and do that on the other side since everything's going to get a little jumbled. So let's take the information we have. We know that x equals 2. We know that m equals 2 square root of 5 over 5. And now we have y as well, which we found was just the square root of 5 when x is 2. To rewrite that, it would just be 2 comma square root of 5 if you want the coordinate point on the graph. And then our tangent line formula is y equals mx plus b. So y is square root of 5 equals our m, which is 2 square root of 5 over 5, times x, which is 2, plus b. Okay, so 2 times 2 right here is 4 square root of 5 over 5. Okay, so I'm going to go ahead and subtract this to this side. So we'll have our square root of 5 minus 4 square root of 5 over 5. And I'm going to move the b to the other side. So we have equals b. With fractions, you have to find a common denominator. Our common denominator in this case would be 5. In order to get the square root of 5 over 1 with 5 on the bottom, you need to multiply it by 5 over 5. So you'll have 5 square root of 5 over 5 minus 4 square root of 5 over 5, leaving you with just the square root of 5 over 5. Because you'll just have 5 minus 4, which is 1. So our formula for our tangent line at x equals 2 is 2 root 5 over 5x plus square root of 5 over 5. So there is our equation. So now that we've done a couple of different problems on what a derivative is, and using that formula, my next video is going to be a little bit more about different ways of finding your first derivative. There's way easier ways than using this formula. But in summary, a derivative is a function of x, is the slope of a tangent line through the point x, f of x, or x comma y. It is also known as your instantaneous rate of change of the function of x. There are different notations for a derivative. The one we have been using is your f prime of x. Another one is just writing y prime. so y with that little 1 up top, or dy over dx, so your derivative of y in terms of dx. And then just to reiterate, your formula for f prime is equal to the limit of h approaching 0 of f of x plus h minus f of x all over h. And remember, h is just your change in x, or triangle x. So you could either write it with h or triangle x, since it's the same thing. And this is Calculus with Lauren, and I see you soon.